Hello everyone, myself Shwetnisha. Today in this video, we are discussing 2024 UPSC Mathematics Optional Paper 1. We'll analyze the questions, we'll discuss the strategies, and except that, I am properly going to solve all the questions. So yes, that's right, I'm going to solve the questions. I'm also going to show you some alternate ways to do the question that would not only save your time in the exam, that will also give you some space there, because you know that you have restricted space, right? So I'll be sharing some insights to help you tackle the first section of paper 1 with the confidence. Okay, so before we get started, I'd like to take a moment to appreciate the great work being done by the Plutus IES Institute based in Karol Bagh, Delhi. They have consistently set high standards in the UPSC coaching, providing top-notch guidance and support to their aspirants. And if you haven't still analyzed the question paper yet, I'll also suggest a video by Priyanka Mam in analyzing this paper, paper 1. You can definitely check out the link in the description below, and we'll start with the solutions now. So without wasting any further time, let's get started. All right. So this is your paper 1, and as you can see, we'll be discussing part A in this video. Let's start. So this is the basic structure of your paper 1. You already know the structure, you already know the pattern. You have 4 questions in part A, 4 questions in part B. We had 2 parts, 2 sub-parts of this E and C of 5th and 6th question in the paper. And first question from here and 5th question from here are the compulsory questions, okay? So we will be discussing these highlighted questions. That means all the questions from part A. All right, let's get started. This is your first question. This was for 10 marks. Each part of first question carries 10 marks. Question says, let H be a subspace of R4 spanned by the vectors V1, V2, and V3. Then find a basis and dimension of H and extend the basis H to the basis of R4. All right. So this was a question from linear algebra. What is given to us? Given is H is a subspace of R4. All right. And it is spanned by these 3 vectors. So H is spanned by V1, V2, V3. Okay. Where we know V1, V2, V3 are given to us. Achha. Now we have to find a basis. Now we know that H is spanned by these V1, V2, V3, but I cannot say that it is a basis unless I check the second property of being a basis. So what is the definition of basis? It has to be linearly independent and it should span the complete vector subspace or space. So spanning is already given in the question. It is spanned by the vectors. I just have to check the linearly independency, right? We have 3 vectors. I can simply consider a matrix capital A whose rows are given by V1, V2 and V3. That is capital A will be equals to, so what are the vectors we have? 1, -2, 5, 1, -2, 5, -3, 2, 3, 1, -4. And the last is 3, 8, -3, -5. 3, 8, -3, -5. Now, this is equivalent to Just apply operations, make it echelon form to check the linearly independence. So just apply R3. Operation on R3 as R3 minus 3 times R1, and on R2 as R2 minus 2 times R1. So it is going to be 1 minus 2, 5 minus 3, 0, 7 minus 9, 2, 0, 14, minus 18, and 4. And you can see it can be further reduced. I can write this as and this is equivalent to, if you apply operation on R3 as R3 minus 2 times R2, then entire third row will become 0, and here we have 0, 7, minus 9, 2, 1, minus 2, 5, and minus 3. All right. Therefore, you can see it's not linearly independent because I have one row entirely 0. So now your spanning set can be reduced to only these two non-zero vectors. Therefore, H has bases 1, minus 2, 5, minus 3. And here we have 0, 7, minus 9, and 2. Okay. So the first question was, then find a basis and dimension. So basis we found, and the dimension is what? And dimension of H is 2. It is the number of elements in the basis set. So it is 2. Next part of the question says that this basis you have to extend. I always say this in the class that you always write the answers where you leave an impression in the answer. To just write the solution and to get the correct answer is not our target. Our target is also to make an impression in the question. That even if one particular topic you know very well, you have prepared very well, so you need to write down that keywords. I hope this question must remind you, especially this last part of the question, where it says extend the basis, should remind you about the extension theorem. So you don't need to write the statement, but even if you do, it's just a one-line statement. You can write that. Even if you don't write the statement, just mention the name of the theorem. It was a naming theorem, right? Extension theorem. So when they say that extend the basis, the extension theorem should come to your mind. And you can write here, because vectors, let it be equals to W1, W2, say. Okay. So because vectors in basis set are linearly independent, therefore linearly independent, therefore W1 and W2 are linearly independent vectors, right? And by extension theorem, every linearly independent set of R4 can be extended to a basis of R4. can be extended to a basis of R4. Okay, you can underline this extension theorem here. And now you know that, okay, the extension is possible. So let's extend it. The questions that we have done in the class, we have done these kind of questions. So the extension actually adds all the standard bases in a matrix and then we try to reduce it, right? So see, now you have to save your time as well as the space. If you do it by the usual way, what is the usual way? Just this. Consider following matrix A as. So the usual way to do this when you extend a basis, you first write W1 and W2 because you want to keep them in your basis set. So you write 1 minus 2, 5 minus 3, 0, 7 minus 9, 2. And then you write 4 standard bases. R4 dimension is 4, so we have 4 vectors in the basis set. What are the standard bases? Standard bases is 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Right. And now you reduce it. You know that when you reduce it to the echelon form, then you are not allowed to make any changes in the first two because I want to keep them as it is in the basis set that I want. So you need to make this part, right? Or in fact, yeah, this part you want to make entirely 0, right? Yeah. So now you see, it's possible to do that. It's not like it's not possible, but it will take so much of time and all those complex calculations are involved here. But still, if you just want to verify and go through the calculations, beta, it will be reduced to this form. So first row will be as it is, 0, 7 minus 9, 2. 0, 0 minus 17 by 7, 17 by 7, 0, 0, 0, 1, 0, 0, 0, 0. By applying all the sets of elementary operations, you can get to this. But again, this will not be a wise choice in the exam. So what is the alternate? How can I extend it? You see, what is your target? Even if you try this method, what is your target? At the end, you want echelon form, right? So except these two, I want two non-zero rows such that it will make it linearly independent, right? So why don't we just add two rows by ourselves so that I get an echelon form also, so that there is no confusion in whether I have linearly independent vectors or not. I'll choose two rows over here so that it just looks like echelon form. It is the echelon form, right? So this part, obtaining your echelon form and obtaining your extension of basis by this method will not be a good wise choice in the exam, right? So what we need to do directly, by extension theorem, every linearly independent can be extended to the basis. Therefore, we can consider look at this. We already have 1 minus 2, 5 minus 3, 0, 7 minus 9, 2, 0, 0, 1, 0, 0, 0, 0, 1. I have added two more vectors which do not disturb the linearly independent property of the two vectors because it's a echelon form, and I can see the rank is full. The rank is 4. Okay? We can consider this, which is echelon form. Echelon form, it implies 1 minus 2, 5 minus 3, 0, 7 minus 2, 2, 0, 0, 1, 0. And 0, 0, 0, 1. It implies this is extended basis of R4. All right, that was your question number 1. Next. Question 1B part, also for 10 marks. This was also from linear algebra. And please note that the question number 1 is a compulsory question. So all these questions are compulsory. You have to do here, you don't have any choice. Let T be from R3 to R3 be a linear operator, and B is V1, V2, V3, be the basis of R3. Please note that V1, V2, V3 are not given to us, but their images are given. I don't know. See, I can take that to be the standard basis, but I have to talk in general because I have to talk in terms of V1, V2, and V3. All right. There is a result which says if you have basis set over here, V1, V2, V3, right? This is R3. And here I have a basis set. This is a basis set. You find image under the transformation. So you will get T of V1, you will get T of V2, you will get T of V3. So this set that you have obtained, it may not be the basis, because the problem is that linearly independent set may or may not map to linearly independent set by the transformation T. Okay, so that's why I can't say that this is the basis of the range of this T, but I can definitely say that it spans your range of T. Okay, so the basis, if you apply the transformation on the basis set, so it does not preserve both the properties of being the basis. First property is linearly independent, second property is spanning. It only preserves the second part. It does not preserve the first part. Okay, so I cannot say that this is basis, but I can definitely say that T of V1, T of V2, T of V3 can span the complete range space of T. I hope I'm clear here. Let's start. So they are asking about basis for the range space and the null space as well. So let's find out. First of all, if B, V1, V2, V3 is a basis set of R3 and some X belongs to R3, then that X can be definitely written as alpha V1 plus beta V2 plus gamma V3 for some alpha beta gamma belongs to real. Field is real, obviously, it's given also. So every vector from R3 I can write as a linear combination of the basis vector. That is the job of basis vector, right? So that's what I have done. I have taken alpha beta gamma for some random for an arbitrary element X from R3. It implies, what is T of X? It implies T of X is alpha outside T of V1 plus beta outside T of V2 plus gamma T of V3. So this is going to be T of V1 is given to us alpha of 1 comma 1 comma 0 plus beta of 1 comma 0 comma minus 1 plus gamma of 2 comma 1 comma minus 1. So this is going to be alpha plus beta plus 2 gamma, alpha plus gamma, and minus beta minus gamma. Now, look at the range space. What will be range space? Let's just apply definition. Range space of T is T of X, where X belongs to R3, right? It implies it is alpha. This I have solved T of X, so I'll substitute the value. This is alpha plus beta plus 2 gamma, alpha plus gamma minus beta minus gamma, where these alpha, beta, gamma are from, can be any real number. Alpha, beta, gamma can be any real number. So it's easy to see that I can write it as the linear combination. All the vectors over here can be written as alpha times 1 comma 1 comma 0 plus beta times, here we have 1 comma 0 comma minus 1 plus gamma times 2 comma 1 comma minus 1, such that again alpha, beta, gamma are from the real. Now what? I can say that this is a linear combination of a set containing 1 comma 1 comma 0, 1 comma 0 comma minus 1, and 2 comma 1 comma minus 1. I can't say that it is a basis because it is just a spanning set. If I can prove that it is linearly independent, then I can say that this is the basis. If it is not linearly independent, then I can reduce it to the to a basis. Okay. So consider we are checking linearly whether these vectors are linearly independent or not. So consider a matrix A equals to containing these rows 1 1 0 1 0 minus 1 2 1 minus 1. To check linearly independent, you can find determinant also. You see, that is also giving you the answer, because if the determinant is coming out to be 0, then they are dependent. But the problem would be that in that case, you need to do extra calculations for finding the reduced vectors which are linearly independent also, and they will span the complete range also. So instead of checking linearly independent by finding the determinant, we'll try to find echelon form. So echelon form of this would be 0, minus 1, minus 1, 0, minus 1, minus 1, 1, 0, 0, 1, 1, 0, which is equivalent to 1, 1, 0, 0, minus 1, minus 1, 0, 0, 0. So as you can see, it has been reduced. Therefore, what is the basis then? Therefore, basis of range of T is 1, 1, 0, because now it spans your range space also and they are linearly independent. This is the basis. Next, we have to find the basis of range space. That is done. Find the basis of null space also. So again, let's apply what is the definition? Null space of T, that is equals to all the vectors from R3 such that when we apply transformation on it, it maps to 0, 0, 0. Right? It implies if that x can be written as alpha v1 plus beta v2 plus gamma v3 belonging to R3, then what is this T of x turns out to be? T of x turns out to be, here when x I have taken this part, then we have calculated T of x also for this particular x. So if x is this, then what is T of x? T of x is alpha plus beta plus 2 gamma, alpha plus gamma and minus beta minus gamma. Alpha plus gamma minus beta minus gamma, that is equals to 0, 0, 0. All right. Solve. Alpha plus beta plus 2 gamma is equals to 0. Alpha plus gamma is equals to 0. Minus beta minus gamma is equals to 0. There are three values here. Solve them. If I solve, I can just solve it from here as well. Okay. So gamma from here is what? Gamma is minus beta, right? If you substitute it here and here, so you will get, let me name them, 1 and 2. So from 1, alpha plus beta is equals to minus 2 minus beta. And from 2, alpha minus beta is equals to 0. So this gives me, okay, there was no need of that. No? So we can just take plus 2 times minus beta is equals to 0. So it would give me alpha minus beta is equals to 0. I'm not getting anything, any value from here. So alpha will be equals to beta. Therefore, from 3, beta is also alpha, then gamma is minus alpha. So I have everything in terms of alpha now. Okay. So therefore, null space can be written as, therefore, null space. So basically, these conditions gave me some relations between alpha, beta, and gamma, and that I'm going to substitute here. So what is this? This is, therefore, null space of T is equals to alpha V1. What is beta? Beta is also alpha. So plus alpha V2. What is gamma? Gamma is minus alpha. So minus alpha V3, where this alpha can be any real. So this is, beta, don't forget that V1, V2, V3 are the vectors. They are vectors from R3. Alpha is a real number. So alpha can be taken common. And what is this V1 plus V2 minus V3? Alpha belongs to real. That is a vector. So that means null space is generated by only one vector, which is this. It implies it is generated by it is generated by only one element, V1 plus V2 plus minus V3. I can say that this is the basis only if this is linearly independent. So a singleton set is linearly independent if and only if it is a non-zero vector. So what if it is 0? Now, V1 plus V2 minus V3 cannot be 0 because in if it is equals to 0, then it's like writing V1, V2, V3 as a linear combination. How can linear combination of them be 0 for non-zero constants? They are linearly independent. Look at the coefficients, 1, 1 and minus 1. Right? So, or you can write now if possible, let this is equals to 0. It implies 1 times V1 plus 1 times V2 plus minus 1 times V3 is equals to 0. It implies V1, V2, V3 are linearly dependent vectors. And that's a contradiction. That is a contradiction. We use this symbol for contradiction. You have to also say why this is a contradiction, because it's a basis. Because B is a basis set. It cannot be linearly dependent because B is basis set. Therefore, V1 plus V2 minus V3 is non-zero. So I can say that it is linearly independent and I can say that it consists of the basis. Therefore, it implies basis of null space is V1 plus V2 minus. That is the basis. You can also see here verification of rank nullity theorem. This is coming out to be one dimension and it is coming out to be 2 obviously, and 1 plus 2 is 3, which is the dimension of the vector space R3. So definitely it is satisfying rank nullity theorem. Next. Basis of, this is the answer. And this is the answer. Basis of null space, basis of range space. In the last question, find the bases and dimensions. So highlight that. H has a basis and dimension this. And this is the extended basis, or you can say required basis of R4. Let's come to first C part. Discuss the continuity of the function. Okay, so this was a very easy question. It was from calculus. Very easy. Discuss the continuity of this function. So what is f of x? It's a little blur over here, so I'll write the function. Given is fx is equals to 1 upon 1 minus e raised to the power minus 1 by x non-zero, and x is equals to 0. You have to discuss the continuity of the function for all values of x. Okay, see, this is definitely a continuous function if at a point which is not equals to 0, because you have to discuss for all values of x. So you have to discuss for 0 separately, because I can see that 0 can create a problem. 0 is where the function breaks, and for the values other than 0, there will be no problem. So let's start. First of all, let x is equals to a is non-zero. Then you can simply write left hand limit x tends to a negative of fx is equals to limit x tends to a negative of 1 upon 1 minus 1 upon x. That is equals to 1 upon 1 minus 1 by a. That is equals to limit x tends to a positive also. That is equals to your right hand limit. Just you have to mention it, because they are saying to you to discuss for all values of x. So you will not just discuss for 0. Mention that for all values other than 0, it is continuous. F of or limit x tends to a positive f of x. Also f of a is not equals to 0. So something which is not equal to 0, then this is the function. You just substitute. Also f of a is the same. Therefore, f of a negative is equals to f of a. Left hand limit or at a, right hand limit at a is equals to the value of the function. It implies f is continuous at x is equals to a. Okay, now let us consider that 0. Now consider limit x tends to 0 negative of f of x. That is equals to limit h tends to 0, 1 upon 1 minus e raised to power minus 1 by h. So what is this? This is limit h tends to 0. Now we can, this will be minus h. No? X is replaced by, x here is replaced by 0 minus h. So it will be minus h. So it is 1 upon 1 minus e power 1 by h. Now just try to substitute. See, if you substitute 0 here, please do not show the substitution because see, I cannot write 1 by 0. It is only approaching towards 0. So please don't write it 1 by 0. Although in the calculations, you can do that. In the rough calculation, you can see that, okay, 1 by h is actually 1 by 0, which is infinity. So e raised to the power infinity will be infinity. So the denominator is 1 minus infinity, which goes to the infinity. And 1 upon infinity is going to be the 0. Okay, so you can write the answer to be 0, but don't write it in fear, 1 by 0. That doesn't make any sense. That's not defined in mathematics. And what is right hand limit? Let x tends to 0 positive. F of x is equals to limit h tends to 0, 1 upon 1 minus e raised to the power minus 1 upon h. Okay. Yeah, over here, if you substitute, now see, in the rough work, I'll show you. Now, in the denominator, I have 1 minus e raised to power minus 1 by 0. So, it's minus infinity. 1 minus e raised to power minus infinity. To make that to be positive infinity, I can write 1 minus 1 by... See, remember, everything is happening in the denominator here. E raised to power infinity. So, it is 1 upon 1 by infinity, which is 1 minus 0. Which is 1 minus 0, which is 1. All right. So the denominator approaches to 1 here. So the complete limit is 1. Since left hand limit is not equals to right hand limit, therefore f is not continuous at x is equals to 0. Also note that continuity is only discussed at the point which is in the domain. Here, every point, every real number was in the domain. That's why it was important for to discuss for all x belongs to real. If let's say if you have a function where 0 is not even in the domain, then you cannot discuss the continuity at 0. No matter even if the left hand limit is coming out to be equals to right hand limit, if that is not in the function, you will not talk about its continuity. So when they are asking about the continuity of the function, you can talk about, you have to talk about only the points or only the points that are in the domain first. Here, every point was in the domain. That's why I have discussed, every point means every point from the real number. So that's why I have discussed for all the real numbers, non-zero and 0 also. Next question was also from the calculus. Again, it carries 10 marks, very easy question. Expand ln x in the power of x minus 1 by Taylor's theorem. Whenever we have a naming theorem, we first state the theorem. Okay, this is called a good answer writing. First, you state the theorem. Even if it is not asked, obviously you have to manage your space. You prefer that if you have the space. So what is the theorem? What does it say? Taylor's theorem. Taylor's theorem provides a way to express a function as an infinite sum of terms. F of x is defined as f of a plus f dash a x minus a divided by 1 factorial plus f dash a, f double derivative a, x minus a square divided by 2 factorial plus and so on. Yeah, it's an infinite sum, so it uh, will be as it is. Now x that we have defined, it is actually expressed in a neighborhood of a. Okay, so where this x belongs to some neighborhood of a with the delta radius, let's say. So in a small neighborhood of a, I can express my function as an approximation to a polynomial. This is a polynomial, right? So this we can see. In the question that we want, we have to express ln of x in the power of x minus 1. To do that, you start by taking let f of x is equals to natural log of 1 plus x. Right? Just compare. I'm taking this to be ln of 1 plus x. And what I'm taking a and delta, a I'm taking to be 0 and delta I'm taking to be 1. So basically I'm defining my function in a neighborhood of 0 with a radius 1. So now this is equals to, according to Taylor's theorem, I can write this function. See, this is not a polynomial. Log x is not a polynomial, but we are approximating it with the infinite sum of terms using the Taylor's theorem. So this is equals to, what is it? F of a. So what is f of a? You substitute this as 0. This is ln of 1. So it is 0. First term is 0 plus. Next term is do the derivative. Do the derivative. Derivative of, you can do this calculations separately also. Let's take 4 terms at least. Here, f dash x will be equals to 1 by 1 plus x. But we want f dash a. So let's substitute the value of a, which is 0 in my case. So it is going to be 1, right? F double derivative of x. Do the derivative again. So double derivative of 0 is coming out to be minus 1. Let's find out 2 more. Third derivative is going to be, this is minus 2. So it's 2 divided by 1 plus x power cube, which implies f triple derivative at 0 is 2. And f fourth derivative is minus 6 divided by 1 plus x raised to power 4, which implies f fourth derivative at 0 is minus 6. All right. So therefore, I can write, therefore, by Taylor's theorem, what is f of x, which is ln of 1 plus x, that is equals to, the first term was coming out to be 0, right? If I directly substitute, it will be log of 1, which is 0, plus f dash a, that is 1. So it is plus 1 times x minus a, so it's x because a is 0, divided by 1 factorial, plus f double derivative of 0 is minus 1, so it's minus 1 x square by 2 factorial. Next, 2 times x cube by 3 factorial plus minus 6 times x raised to power 4 by 4 factorial, and so on. And so on. This is the Taylor series expansion of ln of 1 plus x. But what they're asking is, they're asking ln of x in the power of x minus 1. What I have calculated is ln of 1 plus x in the power of x. So it's almost the same. I just need to do one small change, which is replacing my x with x minus 1. Now replace x with x minus 1. We get ln of, here if I replace this x by x minus 1, so this plus 1 and minus 1 cancels and I'll get log of x. So log of x is equals to, and this side will have x minus 1 minus x minus 1 whole square by 2 factorial plus 2x minus 1 cube by 3 factorial minus 6x minus 1 raised to power 4 by 4 factorial, and so on. So first part is done. Expand log of x in the power of x minus 1. Here is log of x, here is x minus 1. So we have done that. Next part of the question is, next it says, and hence find the value of log of 1.1 correct up to 4 decimal places. Okay. For log 1.1, what I have to substitute it? Because here I have x. So I'll just substitute x as 1.1. For x is equals to 1.1. For x is equals to 1.1, log of 1.1 is equals to 1.1 minus 1, 0.1. So it's 0.1 minus 0.1 square divided by 2 factorial plus 2 times 0.1 cube by 3 factorial. And the question asks only for if I and this would be 6 0.1 raised to power 4 divided by 4 factorial, and so on. So it can be reduced to 0.1 minus 0.01 divided by 2 plus you can cancel this 3 with the 3 factorial, only 3 will be left. So it's 0.001 divided by 3 minus, again here if 6 will be cancelled, 6 is just 3 factorial, so it will be 4 in the denominator. So 0.0001 divided by 4. If we have to approximate up to 4 correct decimals, so this is it. So that is equals to 0.1 minus 0.005 plus 0.0003, and we don't need this because here I am getting 4 digits, right? So this is equals to what? 0.095 plus 0.0003, which is 0.0953. This is correct up to 4 decimal places. Right? I don't need that last one, in fact. One more thing, you can also reduce the expression that we have obtained for log x, like the way I have reduced over here. As you can see, the denominators are 2, 3, 4. So you get a pattern here with a plus minus, with the alternate sign. So this can also be written as, or ln of x is x minus 1 minus x minus 1 square by 2 plus x minus 1 square by 3 plus, not plus, minus x minus 1 raised to power 4 by 4 and so on. This is a more simplified form. That was your D part. Next, one E part from analytic geometry. Analytic geometry. Very, very easy question. We have done this question in the class also. We have done all these kind of questions in class, and mostly, not mostly, all questions from analytic geometry were from the book that we follow. I say this multiple times that P.N. Chatterjee is the best book for analytic geometry. So all the questions you can verify by yourself, all the questions were from P.N. Chatterjee. Even if you follow some other book, if you see, all are just this subset of P.N. Chatterjee. P.N. Chatterjee is a superset. All the questions, everything is over there. Okay, sure. Next, let's start this part. Find the equation of a right circular cylinder which passes through circle this. So, circle is given to us in the form of a intersection of a sphere and a plane. This is this circle, but it is given in the form of a sphere, intersection of a sphere and a plane. That is the plane. Now look at this. Find the equation of cylinder. I have to make cylinder through this circle. So the generator of cylinder will be like this. So if I take a generator which is passing through alpha, beta, gamma, it has to move along the circle in such a way, because it's a right circular cylinder, so it has to be at a constant distance from the center of the circle. Okay, or I can say it has to be always parallel to this line. This line. And this line is perpendicular to your plane and passing through the center of the circle or center of the sphere also, I can say. All right. So circle is given by given circle is x square plus y square plus z square is equals to 9, comma x minus y plus z is equals to 3. There is one more way of writing this circle, or we can reduce it to x square plus y square if I take, no, before doing that, let's do one thing. Circle is given to us. Let us just try to find the equation of the generator, because that line will generate your whole cylinder and that will give you the equation of the cylinder. So let's say, let equation of line through circle 1 through circle 1 and passing through alpha, beta, gamma is, let B. X minus alpha by A is equals to y minus beta by B is equals to Z minus gamma by C. Right now, it is just passing through circle. But if I assume it to be the tangent of this sphere, basically, see, I can take any line, like this is also a line, but this is not a generator. This is also a line passing through alpha, beta, gamma, but this is not a generator. In order to be this as generator, it has to be perpendicular to the plane also. So if it is perpendicular to the plane, then it means it is parallel to normal of the plane. Normal of the plane has direction ratios given by the coefficients of x, y, z. Now, direction ratio of normal, direction ratio of normal of plane x minus y plus z is equals to 3 is 1 comma minus 1 comma 1. So basically, one by one, I'm applying the conditions, all the conditions, so that I can say this line is actually the generating line. Right now, it is just passing through alpha, beta, gamma. And now I have taken the condition that it is perpendicular to the plane. So which means now direction ratios of normal of plane is this. If line 2 is perpendicular to plane x minus y plus z is equals to 3, then line 2 is parallel to normal of plane, which implies their direction ratios are proportional. The direction ratio of line 2 is ABC. Direction ratio of this is 1 minus 1, 1. There it implies A upon 1 is equals to B upon minus 1 is equals to C upon 1. Therefore, so equation 2 becomes, I can take the values of ABC to be 1 minus 1, 1. X minus alpha by 1 is equals to y minus beta by minus 1 is equals to z minus gamma by 1. But now, if a point is passing through alpha, beta, gamma and perpendicular, it is not enough to say that it's a generator. Because now this line can be here also, like not touching the circle or not touching the sphere. Okay, so in order to have the intersection, yeah, it must touch the surface of the sphere only at one point, right? So what does a general point looks like on this line? Any point on line given by 3 now, line 3 is of the form, just equate it with k, so it will be k plus alpha, find out x. If you equate it with k, find out alpha x. X is k plus alpha minus k plus beta and k plus gamma is of the form this. Now, which particular point I'm looking for? I'm looking for a point right here, this point. I am looking for a point which is on the plane also, and it is on the sphere also. Because now I have to apply the last condition, that is, it should touch the circle. It should follow the path of the circle. That means it should touch sphere also and it should touch plane also. So one by one, we'll apply the condition. If it lies on plane, if this point lie on plane, x minus y plus z is equals to 3. Then just substitute the value x minus y plus z. Then k plus alpha minus, so plus k minus beta plus k plus gamma is equals to 3. So 3k plus alpha minus beta plus gamma is equals to 3. So what is k? K is 3 minus alpha plus beta minus gamma divided by 3. And it has to be on the sphere also. Also, if, let me take it as A point. Also, if A is on given sphere, then x square plus y square plus z square is equals to 9. So divided, first open this will be a 3k square plus alpha square plus beta square plus gamma square. Then we'll get plus 2 common, alpha minus beta plus gamma times k is equals to 9. Now this is 1 by 3 k square. What is k square? K is this value. Now you can substitute 3 minus alpha plus beta minus gamma divided by 3 square plus alpha square plus beta square plus gamma square plus 2 alpha minus beta plus gamma. And again, the value of k will be substituted here is this 3 minus alpha plus beta minus gamma divided by 3 is equals to 9. let's open this. It is going to be 9. Okay, 9 I have taken here. So I think, just a second. Let me take the 9 here only, and let me just take this as 3. So it would be 9, because if I consider this as 3 minus alpha minus beta plus gamma whole square. 3 by 9 So let's continue. So this is 3 by 9, and if I open the square here, that would be 9 by 9 is outside, and this is 9 plus alpha square plus beta square plus gamma square minus 2 alpha beta, no, minus 2 alpha beta, yes, then minus 2 beta gamma and plus 2 alpha gamma, and then minus 6 alpha plus 6 beta minus 6 gamma. That's it. Plus alpha square plus beta square plus gamma square plus 2 by 3 plus 2 by 3 of, open this is 3 alpha minus alpha square plus alpha beta minus alpha gamma minus 3 beta plus alpha beta minus beta square plus beta gamma plus 3 gamma minus alpha gamma plus gamma beta minus gamma square is equals to 9. Let me take the LCM this side. So in a broad sense, I can say that I have this term and the first bracket, the third bracket. We have 3 brackets here. So if I take the, okay, this is also 1 by 3. So 3 is the LCM, right? It will go there. It will be 27. So it implies this is going to be 9 plus alpha square plus beta square plus gamma square minus 2 alpha beta minus 2 beta gamma plus 2 alpha gamma minus 6 alpha plus 6 beta minus 6 gamma plus 3 alpha square plus 3 beta square plus 3 gamma square minus, let's multiply this 2 here. So 6 alpha minus 6 alpha square plus 6 alpha beta minus 6 alpha gamma minus 18. 2 will be multiplied. 2, 3 is 6. 2, 2, 2, 6 beta plus 2 alpha beta minus 2 beta square plus 2 beta gamma plus 6 gamma minus 2 alpha gamma plus 2 gamma beta minus 2 gamma square minus 27 is equals to 0. First, let's collect all the alpha square. Alpha square I have here 1 plus 3, 4. 4 minus 2 is 2. That's it. So we have 2 alpha square. We have 2 alpha square. Then we have beta square again 1, 4 and minus 2. So 2 plus 2 beta square. Similarly, we'll have 2 gamma square from here, here and here. Right. Now, this, this, and this is used. Next, alpha beta minus 2, and we have plus 2 cancels. Do we have any other alpha beta? Yes, we do have 2 alpha beta here. So plus 2 alpha beta. Now beta gamma minus 2 beta gamma plus 2 beta gamma cancel. And here we have 2 beta gamma. So plus 2 beta gamma. Alpha gamma. 2 alpha gamma minus 2 alpha gamma cancel. And we are left with minus 2 alpha gamma here. Minus 2 alpha gamma here. So this is used, and this is used. Now let's see all the alphas. Minus 6 alpha, minus 6 beta, minus 6 alpha. So alpha we have minus 6 minus 6. Plus and minus cancel, minus and plus cancels. 6 alpha I think should also be cancelled. 3. This is plus, right? Yeah, this is plus. So this also cancels. So alpha, beta, gamma are completely gone. And now I have a constant, which is 9 minus 27 minus 18. Minus 18 is equal to 0. It implies alpha square plus beta square plus gamma square plus 2 times alpha beta plus beta gamma minus alpha gamma minus 9 is equals to 0. So here, see, the generator will generate the complete cylinder, right? Now, if I have to find the equation of generator, that is locus of all these lines, generators, where this alpha, beta, gamma was taken a random point on the generator and hence on the, it will move, right? Alpha, beta, gamma will move on the cylinder. So I have to find the locus of this alpha, beta, gamma that will generate the complete cylinder like this. All right. So alpha, beta, gamma, I have the relation over here. Therefore, locus of alpha, beta, gamma, which is required cylinder, is x square plus y square plus z square plus 2xy plus yz minus xz minus 9 is equals to 0. Okay, 2 will also be cancelled. Huh? Yeah, so this is equals to 0. That is your answer. This is your first question. Now let's go to the second one. Second question, first part, consider a linear operator. It is again from linear algebra. Consider a linear operator T on R3 over R defined by this. Is T invertible? T is invertible if and only if, just apply the basic theory of the functions. One function is invertible if and only if it is 1, 1 and not 2, right? So there are two possible ways. I'll show you both of them to do this part only, invertible. See, for invertible, we know a theorem which says that T is 1, 1 if and only if kernel of T is 0. Null space has only 0 in it. That means nullity is 0, right? So to prove that this is 1, 1, what I can try is to find out the kernel. Given is T operator from R3 to R3. Right. So T of XYZ is given to be 2x, comma 4x minus y, 2x plus 3y minus z. Now, what is kernel of T? All the elements from domain vector space R3 such that when we apply transformation on it, answer is 0, 0, 0, which implies this is equals to all x comma y comma z such that 2x comma 4y minus y comma 2x plus 3y minus z is 0, 0, 0, right? Which clearly implies that 2x is equals to 0, which implies x is equals to 0. 4x minus y 0 implies y 0. And the last 2x plus 3y minus z is equals to 0 implies z is equals to 0. Therefore, the only possibility of x, y, z is 0, 0, 0. Therefore, kernel of T is 0, 0, 0. It is if and only if T is 1. Okay. When T is 1, 1, it implies nullity of T is 0, and using and by rank nullity theorem, rank of T plus nullity of T is dimension of domain vector space. Domain vector space and codomain vector space both are same here. It is dimension of R3. So that is rank of T plus 0 is 3. So rank of T is 3. And what is the dimension of codomain vector space? That is R3. That is also 3. So since rank of T is equals to dimension of range space of P, it implies R is on 2. Okay. So, sorry, T is on 2. It implies T is on 2, which proves that T is invertible. Therefore, T is invertible. But looking at the second part of the question, this complete theory not only wastes your time, also wastes the space. So this is correct way, but it should not be the, just to remind you this concept, I have shown you this alternate way to do the first part. But you see, look at the second part. If yes, justify your answer and find T inverse. Actually, to find T inverse, we need to do some more calculations, but that can be totally avoided if I use some another way to prove this invertible part. And what is it? What is it? So I'll remove this part. No, 1, 1, you can keep it like that. 1, 1, you can keep it like that. Onto, let me change. So this onto part, I have an alternate way to for the onto part that will also solve that invert to find the t inverse. That will also solve that. Okay. So what is the meaning of onto? Like, what is the definition of an onto function? Onto function or a onto linear transformation over here is that we're skipping this part. Okay. So what is onto? If I take any point from your R3, let's say I have taken some x comma y comma z, and I can show or I can find some ABC whose image is that point, then I can say it's an onto transformation. Onto transformation means every image in the codomain has a pre-image. Okay, so we'll start by taking a x, y, z in the codomain and we'll try to find ABC in the domain whose image is that x, y, z. Okay, so let x comma y comma z belongs to codomain, because domain and codomain are same, so that's why it's better to write down where I'm talking about domain and where I'm talking about codomain. So let x comma y comma z belongs to codomain of R3. So then if there exists, now I'm not saying that there exists, but if there exists some a comma b comma c in domain R3 such that t of a comma b comma c is xyz, then what? It implies apply the transformation. Transformation is 2x 4x minus y, 2x plus 3y minus z. So 2a 4a minus b and 2a plus 3b minus c is x comma y comma z. I have to find the existence of ABC. So if I'm able to find a unique value of ABC from here by equating this left hand side and right hand side, then I can find ABC. So what is A? A is x by 2, right? 4 times x by 2. This is 2x, yes, okay. So 4 times x by 2 minus b is equals to y. So what is b from here? It implies b is equals to 2x minus y and 2 times x by 2 plus 3 times 2x minus y minus c is equals to z. Find out c from here. X plus 6x minus 3y minus c is equals to z. It implies c is equals to minus 7x plus 3y plus z. So this becomes, this is minus c. So c is 7x minus 3y minus z. So yes, I can find A, B, C uniquely in terms of x, y, z. So therefore, T of, what is A? A is x by 2, right? T of x by 2, 2x minus y and 7x minus 3y minus z is going to be x comma y comma z. All right. So, and because for any element in codomain, you found an element in domain whose image is xyz, it implies T is onto and hence invertible. How that is going to help you to find your T inverse here. For T inverse, for T inverse, we have T inverse of, we have if T of XYZ, or if T of ABC here is XYZ, it implies T inverse of XYZ would be ABC. And what is ABC? X by 2, 2x minus y, and 7x minus 3y minus z. That is the T inverse. So the calculation that you have done in the onto part was useful here. Since T is both 1, 1 and onto, therefore T is inverted. This is the proper justification. Let's start with the second part, 2B. Okay, and this was not for 10 marks. This was for 15 marks. But it was very easy question. This is also for 15 marks. This was from calculus, Jacobian chapter. U is given, V is given, then find the Jacobian. Directly they are asking Jacobian. Even if they would not ask the Jacobian, this first part, and they are asking, are U and V functionally related? So over here, you still have to find the Jacobian to answer that question. Let's find it. Del U comma V divided by del X comma Y. That is defined as the determinant. Del U by del X, del V by del Y, del V by del X, and del V by del Y. That is equals to del U by del X. With respect to X, it is going to be 1 minus xy, 1 minus x plus y minus y divided by 1 minus xy whole square. And this second, let me write it here. Then we have with respect to y. With respect to y, it would be 1 minus xy minus x plus y is also minus x divided by 1 minus xy whole square. And v with respect to x is 1 upon 1 plus x square, and here it is 1 upon 1 plus y square. Find out this determinant. That is going to be equals to 1 minus xy plus xy plus y square divided by 1 minus xy whole square times 1 upon 1 plus y square minus 1 minus xy plus x square plus xy divided by 1 minus xy square. multiply 1 upon 1 plus x square. So minus this and cancel, and 1 plus x and 1 plus x cancel from here. This also cancel, 1 plus y square, 1 plus y square cancel, and it is 1 upon 1 minus xy whole square minus 1 upon 1 minus xy whole square. It's 0. So since Jacobian is 0, therefore u and v are functionally related. And what is the relation? Now there is no method or the formula by which you can find the relation. In this part, it was very obvious. Just look at the expressions of u and v. You look closely, this is a very famous formula, identity, trigonometric identity. Remember, we know tan inverse of x plus y divided by 1 minus xy is equals to tan inverse x plus tan inverse y. It implies tan inverse, beta, this is u and this is v. So u is tan of v. All right. If yes, find the relationship. So we found the relationship. This is it. So first part was, are they functionally related? Yes, they are functionally related. And what is the Jacobian? This right here is the Jacobian. 3 parts of the question were there, and these are the 3 answers. All right. Next we have C part. This question was for 20 marks. And this I have mentioned in PN Chatterjee multiple times that beta, when you have to find image, please do not confuse it with the mirror image. This is not mirror image in the plane, right? We have a line, we have a plane. You don't have to find mirror image. Mirror image is this. You have to find projection. Okay, in this question, you have to find projection. Only thing you have to see, first of all, that whether this line is intersecting the plane or parallel to the plane. In order to do that, you find a point, a general point, substitute in the plane, and you see whether you are getting the value of t or not. So given line is, you can very easily write its symmetrical equation of this line, which is x minus 3 divided by minus 6, y divided by 2, or I can write y minus 0 divided by 2, and z minus 3 divided by minus 2 is equals to t. Any point. Let me also write plane over here. Given line is this, and plane is 3x plus 4y minus 5z plus 26 is equals to 0. Point of intersection of line and plane is given by so 3 times minus 6t plus 3 plus 4 times 2t minus 5 times 3 plus 2t plus 26 is equals to 0. if I'll be able to solve the t from here, that means I have an intersection point. So if you solve it, it will be 9 minus 15 plus 26 minus 18t plus 8t minus 10t is equals to 0. So it's 20 minus 20t is equals to 0. And t is equals to 1. Therefore, now you can see, now you can draw the diagram like this, that you have a plane and then you have a line, right? This is the line, and definitely the line is has an intersection. Line is intersecting, and let it be this A point. Okay. So what is A point? A point is, this is the point. Just substitute T as 1 here. So you will get your first, that point of intersection you will get. Here is the point. Just substitute T. If I substitute T as 1, it is minus 3, 2, comma 5. This is the point. Therefore, this is point of intersection of line 1 and plane 2. Once I have that, how to find the projection? We have to take another point on the line. One another point on the line, let it be B. Every point on the line is obtained by substituting T to be a real number. So if I substitute T other than 1, I'll get another point. I'll take that to be B. So let's make it very easy. Let's take T is equals to 0. So for T is equals to 0, there is another point which is 3, 0, 3. Right? You substitute T as 0. This is gone, and this is gone. So 3, 0, 3. Let B is equals to this. Now, next you have to find equation of this perpendicular line. This is perpendicular to your plane. And let this foot of the perpendicular be C point. What is equation of this BC? I know B is 303. And what is the direction ratio? Direction ratio, this is perpendicular to the plane. So direction ratio is same as the direction ratio of normal. So first of all, direction ratio of BC is direction ratio of normal of plane 2. And what is it? Coefficients 3, 4 and minus 5. So 3, 4 and minus 5 are the direction ratios. This is 3, 4 and minus 5. So you have a point on the line, you have direction ratio of the line, you can very easily find equation. Therefore, equation of BC is x minus 3 divided by 3, y minus 0 divided by 4, and z minus 3 divided by minus 5. And any point on BCA is 3k plus 3, 4k and minus 5k plus 3. Note that this is the point I have taken on this BC. If I want to find in particular this C point, that means C point is on the plane. So that means this point needs to be on the plane. For that, what will be the value of K? And any point on BC is this. If this point is C, then it lie on plane 2, which implies, so what is plane given? This was 3x plus 4y. 3k plus 3x plus 4y minus 5z plus 26 is equals to 0. Okay, so it is 9k plus 9 plus 16k minus plus 25k minus 15 plus 26 is equals to 0. It gives me 50k and it gives me plus 20 is equals to 0. So k is minus 2 by 5. This gives me foot of the perpendicular. Okay. Therefore, C will be equals to, in this point, you substitute k as minus 2 by 5. So this is 3 times minus 2 by 5 plus 3 comma 4 times minus 2 by 5 and minus 5 minus 2 by 5 plus 3. That is equals to, solve it. It is going to be 9 by 5 and it is going to be minus 8 by 5. It is going to be 5. So this is C point, and now you can find your projection. Projection is the line AC. You have to find equation of AC. How? How you can find it? Because you have both the points. You have A also, you have C also. Using point A and C here, equation of image of line 1 on plane 2 is, so x, it was minus 3, A was minus 3, 2 and 5. So x plus 3 divided by, these are the direction ratios would be what? 9 by 5 minus minus 3. 9 by 5 plus 3. 9 by 5 plus 3 is equals to y minus 2 divided by minus 8 by 5 minus 2 is equals to z minus 5 by 5 minus 5. So it is coming out to be x by 3 divided by 24 by 5 is equals to y minus 2 divided by minus 18 by 5 is equals to z minus 5 by 0. You can multiply this by, you can multiply this by 5 by 6. So it implies x plus 3 by 4 is equals to y minus 2 by minus 3 is equals to z minus 5 by 0. That is your equation. Okay, so only one thing I want to say in this question was, please don't confuse that image part. There are many questions of this type in the PNGWG. So image is the projection. Next, third question, 15 marks, again from linear algebra. Let V is M2 cross 2, denote a vector space over this. Okay, so V is given to be M2 cross 2 over R. Write down necessary information mathematically. You don't have to write everything in a statement. I know what does this represent. So I'll not write that this is a vector space of all matrices over reals and everything. I know what it is. So basic information from the question, write it down in the solution. This is given to us. Find the matrix of the linear mapping phi. Okay, so phi is the mapping from M2 cross 2R to M2 cross 2R, correct? It is given by phi of V is this. V is actually a vector in this matrix. So it is a matrix. Okay. So defined as just small v does not give an impression of the matrix representation. So I'm writing it as capital A. Okay. You can work with V also. No problem. This is all given to us. It's 1, 2, 3, minus 1 times A. This is the matrix. This is the transformation. We know that a transformation can be reduced to a matrix. It says find out that matrix with respect to the standard basis. So this is the easiest one. Standard basis, just apply. M2 cross 2R can be easily compared with R4 because it has 4 real numbers, A, B, C, D. So standard basis of M2 cross 2 is the set containing 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1. Now, what is phi of 1, 0, 0, 0? It's 1, 0, 0, 0 times A. A is post multiplication. So 1, 2, 3 minus 1 times 1, 0, 0, 0. Right? This is okay. Also, I will use the notation E1, E2, E3, and E4. Say. So this is equals to multiply. This is going to be 1, 0, 3, 0. So it is 1, 0, B, 0. This is equals to 1 E1 plus 0 E2 plus 3 E3 plus 0 E4. Plus 0 E4. That's what we want. So we get the first column of the required matrix. 1, 0, 3, 0 is the first column. Phi. Similarly, you apply on E2. Now this will be multiplied 1, 2, 3 minus 1 times 0, 1, 0, 0. That is going to be 0, 1, 0, 3. So it is 0 E1 plus 1 E2 plus 0 E3 plus 3 E4. This is the second column. The coefficients are giving you second column. Phi of 0, 0, 1, 0 is 1, 2, 3 minus 1 times 0, 1, 0, 0, 1, 0, which gives me 2, 0, minus 1, 0. So it gives us 2E1 plus 0 E2 minus E3 plus 0 E4. And phi of 0, 0, 0, 1 is 1, 2, 3 minus 1 times 0, 0, 0, 1, which gives me 0, 2, 0 minus 1, 0 E1 plus 2 E2 plus 0 E3 minus E4. Therefore, matrix notation of this, let me take as B. So matrix notation of this phi with respect to B This is the notation of representing a matrix corresponding to a linear transformation with respect to a given basis. If you use anything different than this from any other book, that's fine, right? I usually prefer this notation. So this matrix will be given by, as you can see, first column 1, 0, 3, 0. Then next we have one is 0, 1, 0, 3, 2, 0, minus 1, 0, 0, 2, 0, minus 1. That is the required matrix. What is it asking after that? And hence find the rank. Rank I can find just finding the rank of this matrix. You can very easily reduce it to the echelon form. This is equivalent to 1, 0, 2, 0, 0, 1, 0, 2. And this is just 3 minus 3 times the row 1. So it's 0, 0, minus 7, 0, and 0, 0, 0, minus 7 as well. Here I have applied transformation operation on R3 as R3 minus 3 times R1. And I have applied operation on R4 as R4 minus 3 times R2. All right. And you can see rank is full. Rank of this matrix is 4, which is same as the rank of transformation, which is same as rank of transformation. And because it is equals to, and since rank of 5 is equals to 4 is equals to rank of this V. What, not rank, dimension. What is the dimension of this V? I just said in the beginning that M2 cross 2 can be easily associated with R4. So the dimension of this is same as dimension of R4, which is 4, which is same as dimension of codomain V. Therefore, phi is okay. For invertible, we need 1, 1 and onto both. It just proves onto, but it automatically proves 1, 1 also. It implies phi is onto, and by rank nullity theorem, nullity of this phi plus rank, this is rank phi plus nullity of phi is equals to 4. So nullity of phi is 0. It implies kernel of phi is only the set containing 0. It implies phi is 1, 1. Since phi is both 1, 1 and onto, this is inverted. Since phi is both 1, 1 and onto, therefore phi is invertible. So first part of the question was finding this matrix. So this is the matrix. Next part, finding the rank of phi, which is here. Last part, is phi invertible? Yes, it is. Phi is invertible. Next question. Third question, B part for 20 marks. At the first glance, it looks like a question from the analytic geometry when you see cylinder, angle, height, and everything, cone. So it seems like an analytic geometry question, but it is not. And that's why I always say practice previous year questions only from the question papers, not from the categorized question papers. Like you can find, if you just Google linear algebra questions from the previous year of UPSC, you will get a PDF where all the linear algebra questions are there. From 2020, all the linear algebra question, from 2021, from 2022, all the linear algebra questions will come. But that's not how you will practice previous year questions. You figure out from question paper that which are the questions of linear algebra, which are the questions of analytic geometry. Because if you do categorized, you'll not be able to figure out in the exam that whether this is an analytic geometry question or it's a calculus question. Because this particular question was not from analytic geometry, this is from calculus. Let's see, what is it? It's a very easy question. In just class 12th knowledge is needed for this question. What is it? Find the volume of the greatest cylinder which can be inscribed in the cone of height h and semi-vertical angle alpha. So we have a cone. This is a cone, and we have to find what is what about a cylinder that can be enclosed in this, that can be inscribed in this cone to give me a maximum volume. Find the volume of the greatest cylinder. So what is the greatest cylinder I can inscribe? So a cylinder, you can find it in terms of h and alpha because that is given here. So let us say just a second. Yeah. So if I drop a perpendicular here, this is the center. Let it be D point. Let it be some D point. Let this be some B point. Let this be A. Okay. Let's make R radius over here, which is, this is C. Okay. Theta is given. So this is theta. And H is given. So total height of the cone is given. H is given to be this. Now let's find it. See, we have to maximize the volume. Right? What is volume of cylinder? Volume of cylinder is pi r square and h. H is the height of the cylinder, which is BT. which is BD, right? Pi r square h. Now, I need the value of BD, which I can find uh, in triangle by finding the value of AB first, because total height I know h. If I just subtract AB from here, I'll get BD. And I can find AB in triangle ABC. What is AB? You can find tan. Okay, this is alpha, not theta. This is alpha. So tan alpha is equals to R divided by AB. So what is AB from here? AB is R cot alpha. Therefore, BD is H minus R cot alpha. Right? It implies volume of cylinder is capital V is pi r square, and this is h, which is h minus, means height of the cylinder is h minus r cot alpha. Cot alpha. So V is pi r square h minus r cube cot alpha. See what we'll do here. I want to maximize the volume. If I want to maximize the volume, then that means I want maximum value, right? Maximum value, how can I find out? Finding the derivative, equating it with 0. So dV by dr is equals to h is fixed. Alpha is fixed. Only thing that I can vary here is r, because that is my choice. I can take the radius by myself. So the differentiation will be with respect to r. Pi common, that will be 2rh minus 3r square cot alpha. V is maximum or minimum if this dV by dr is equals to 0, or you can just put dV by dr is equals to 0. So it implies obviously this 2rh is equals to 3r square cot alpha, which gives you the value of r as 2h divided by 3 cot alpha. Now 3 cot alpha. Now this can give me maximum value also, minimum value also. Now we'll find a double derivative. So double derivative is equals to pi common 2h minus 6r cot alpha. Now d square v by dr square at r is equals to 2h divided by 3 cot alpha. What is this equals to? Substitute value of r minus h, 2h divided by 3 cot alpha times cot alpha. It gets cancelled. 3 to 6. As you can see, it's minus 2 pi h. Definitely less than 0. Therefore, this is point of maxima. That means at r is equals to 2h divided by 3 cot alpha. This is just a question from application of derivatives. And the first exercise, in fact, has these kind of questions from class 12th NCRT. At r is equals to this, V is maximum. Therefore, V max is equals to pi. What was, yeah, this is it. So pi r square. Okay, so pi r square, r is 2h by 3 cot alpha square times h minus r cot alpha. So r is 2h divided by 3 cot alpha times cot alpha. This is the maximum value. Cancelled, it's pi 4h square divided by 9 cot square alpha. And this becomes h by 3. So this is 4 by 27 pi h cube tan square alpha. This is the maximum volume. Next. Question number 3, C part, 15 marks. The last question that we did was for 20 marks. And if I compare these three questions, three parts of the third question, then this was the easiest one, considering that it was only from class 12th concept. And you have your 20 marks secured. Question number 3, C part, 15 marks. Find the vertex of the cone. Actually, this question has a simple working rule. You just follow those steps and you can get the vertex of the cone. In fact, this working rule also check that whether the given equation in second degree is representing a cone or not. So I'll solve those steps here step by step. First is make this equation a homogeneous by introducing a variable t. Making given equation a homogeneous equation by introducing a variable t. We get f of x comma y comma z comma t, that is equivalent to, first is this step. So 4x square minus y square plus 2z square plus 2xy minus minus 3yz plus 12xt minus 11yt plus 6zt plus 4t square. This is the first step. Next step is doing the differentiation of this capital F with respect to x, y, and z partially, and t also partially, partial differentiation. So now what is del F by del x? This is 8x plus 2y plus 12t is equals to just a second. Okay. It's 2 del F by del y. With respect to y, it is going to be minus 2y plus 2x minus 3z minus 11t. With respect to z, 4z minus 3y plus 6t, and del F by del t is equals to 12x minus 11y plus 6z plus 8t. Now we solve three of them by substituting t is equals to 1. Okay, so let us solve for x, y, z when t is equals to 1 in del f by del x, t is equals to 1 is equals to 0. This is first equation you have to, this is first equation you have. Del y, t is equals to 1 equals to 0. Del y, del z, t is equals to 1 is equals to 0. Okay, so basically we substitute, this is the third step. Second step is finding all these partial derivatives. Third step is substitute t is equals to 1 in the first three and equate with 0. And solve for x, y, z. So that gives me 8x plus 2y plus 12 is equals to 0. Plus 12 is equals to 0, which will give me y is equals to minus 6x minus 4x. That's true. Next, minus 2y plus 2x minus 3z is equals to 0. Minus 11. So minus 11 is equals to 0. So it implies 2 times 6 plus 4x plus 2x minus 3z minus 11 is equals to 0. Is equals to 0, which gives me 12 plus 8x plus 2x minus 3z minus 11 is equals to 0. So z comes out to be 10x plus 1 upon 3. Right? And last one is, and last equation is this 4z minus 3y plus 6. 4z plus 3y plus 6 minus 3y plus 6 plus 6 is equals to 0 implies using 2 and 3 here. Using 2 and 3, 4 times 10x plus 1 by 3 minus 3 times minus 6 minus 4x plus 6 is equals to 0. Using equation 2 and 3. So this will give you your value of x. What is it? It is 40 x by 3 plus 4 by 3 plus 18 plus 12x plus 6 is equals to 0. So it's 76 x by 3 plus 76 by 3. So x is equals to minus 1 from 2. From 2. Y is equals to minus 6 minus 4 times x. X is minus 1. So it is minus 2. And z. And from equation 3, z is 10 times x plus 1 divided by 3. So it is going to be minus 3. Now, note that these values of x, y, and z, if it satisfies, so this is irrelevant for the question, we don't have to do this part, but I'm telling you anyways that if this x comma y comma z, the values are satisfying del f by del t, just give me the equation. This is equals to 0. If this equation is satisfied by your value of x, y, and z and 1. So if it is equals to 0 at -1, -2, and -3, comma 1, then it represent cone. But that's not what is asked. The question does not says that prove that it is a cone. If it is a cone, if this equation is satisfied, then this XYZ is the vertex of the cone. Here in this question, if you try to satisfy this equation, it will be satisfied this point, no problem, because it is a cone. And hence, therefore, -1, -2, -3 is vertex of cone. This was your third C part. Let's see, fourth question. First question, again from linear algebra. Matrix part. 20 marks question, but again, very easy question. Question says, let A is this, be a 3 cross 3 matrix. You have to find the eigenvalues and the corresponding eigenvectors. So eigenvalue, eigenvector part was very easy. You just have to solve if lambda is an eigenvalue of capital A, then A minus lambda I determinant equals to 0. It implies determinant of 3 minus lambda, 2, 4, 2, 0 minus lambda, 2, 4, 2, 3 minus lambda is equals to 0. So it implies 3 minus lambda times lambda square minus 3 lambda minus 4 minus 2 times 6 minus 2 lambda minus 8 plus 4 plus 4 lambda is equals to 0. So this gives you 3 lambda square minus 9 lambda minus 12 minus lambda cube plus 3 lambda square plus 4 lambda plus 4 plus 4 lambda plus 16 plus 16 lambda is equals to 0. Right? Because actually this is 6. Yeah. Okay. So this is going to give me minus lambda cube plus 6 lambda square plus 15 lambda plus 8 is equals to 0. So lambda cube minus 6 lambda square minus 15 lambda minus 8 is equals to 0. All right. First root, you can try with 1. That is not going to work because 1 minus 6 minus 15 minus 8, that is not going to be equals to 0. Let's try with lambda equals to 1, minus 1. For lambda equals to minus 1 left hand side is equals to minus 1 cube minus, let's simplify it also, minus 6 minus 1 square minus 15 minus 15 times minus 1 minus 8 is equals to minus 1 minus 6 plus 15 minus 8, that is equals to 0, that is equals to right hand side. So lambda is equals to minus 1 is one of the root of equation 1. Lambda equals to minus 1 is root of equation 1. So Now, to find out the other two roots, you can follow that division of polynomials, but instead of that, what you can do is synthetic division also you can do. What is it? You just write -1 over here, first root, and you collect the coefficients where you don't miss any power. It should be the complete polynomial. Like if lambda square is missing, so you will write 0 lambda square, right? So the coefficients are 1, -6, -15, and -8 of equation number 1. These are the coefficients of your x, lambda cube and lambda square, etc. So you write 1 as it is. You multiply -1 with 1 and you write it here. It's -1, right? Now, you add these two, it is -7. You again multiply -1 with this and you write it here, 7. -1 multiplied by -7 is 7. And you add, this is going to be 8. Again, this is going to be -8. Again, you multiply, this is 8, -8 plus 8, 0. This is the remainder, and obviously it has to be 0 because -1 is the root. So when you divide this polynomial by x minus 1, obviously your remainder is 0. And this is your quotient. So therefore, equation 1 can be rewritten as lambda plus 1 times, look at the coefficient, lambda square minus 7 lambda and -8 is equals to 0. So that gives me lambda plus 1. This is lambda plus 1 and lambda -8 is equals to 0. So the three possible values of lambda, -1, -1, -8. Find the eigenvalues and the corresponding eigenvectors. So required eigenvalues, at least I have. Eigenvalues are -1, -1 and 8. Let's find out eigenvectors corresponding to that. For lambda equals to -1. For lambda equals to -1. See. x1 x1, x2, x3 is eigenvector if determinant of A minus lambda is -1 this times, lambda of this times x1, x2, this matrix times x1, x2, x3 is 0, 0, 0. So let's solve it. This is A plus lambda, na? So yeah, this is it. So lambda I have to substitute -1. So it is 3 minus -1, 4, and the last becomes 4, and the middle one becomes 1. So this will be, it implies 4, 2, 4, 2, 1, 2, and the last is 4, 2, 4. 4, 2, 4 times x1, x2, x3. That is equals to 0, 0, and 0. Solve it. This is going to be 2x1 plus x2 plus 2x3 is equals to 0. This is the only equation that you will get here. So x3 is equals to -2x1 minus x2 by 2. Therefore, eigenvector is equals to x1, x2 and x3 are given by x1, x2 and minus x1 minus 1 by 2 x2. That is equals to x1 common 1, 0, minus 1 plus x2 common 0, 1 and minus 1 by 2. x1, x2 cannot be 0, 0. Therefore, eigenvector corresponding to lambda equals to minus 1, eigenvectors are 1, 0, minus 1. And these are the two eigenvectors. You see, we have a collection of eigenvector here. For whatever value you put for x1 and x2, just don't substitute both of them as 0. You can get eigenvector. Once I have substituted 1, 0, and the other time I have substituted 0, 1. So that's how we get the eigenvector. Next, we have to find eigenvector corresponding to lambda equals to 8. For lambda equals to, so this is going to be changed. For lambda equals to 8, x1, x2, x3 for lambda equals to 8, x1, x2, x3 is an eigenvector if a minus 8 lambda is this. So it was 3 minus 8 minus 5, 0 minus 8 minus 8, and this is also 3 minus 8 minus 5. You can try to reduce it, this system of, because it's a homogeneous system of equations, so it can be reduced to echelon form. That will be 0, 0, 0, 0, minus 2, 1. Please, you can solve this part. Please solve it. 4, x1, x2, x3. So basically, to reduce it was, because now it's easy to solve these two equations. And I have, here I'll get two equations to solve, which implies minus 5x1 plus 2x2 plus 4x3 is equals to 0, which gives me x3 as 5x1 minus 2x2 divided by 4 and minus 2x2 plus x3 is equals to 0, which implies minus 2x2 plus 5x1 minus 2x2 divided by 4 is equals to 0. So it gives me minus 8x2 plus 5x1 minus 2x2 divided by 4 is equals to 0, which gives me which gives me 5x1 minus 10x2 is equals to 0. So your x2 is 1 by 2 x1. And this 1 becomes from 1 and from 1. What is x3? x3 is 5x1 minus x1 divided by 4. So it is x1. Therefore, what is x1, x2, x3? x1, x2, x3. x1 will be x1, x2 will be half of x1, and x3 will be x1, which is equals to x1 times 1, 1 by 2 and 1. Therefore, eigenvector corresponding to lambda equals to 8 can be taken as 1, 1 by 2 and 1. This is the second part. Now, what was the last part of the question? Last part of the question was find the eigenvalue and the eigenvector. Hence, find the eigenvalue and eigenvector of a raised to the power minus 15. It was just there for the confusion, but you see, it's very easy. For this, you just need to know two results. First is that first result, you should know that this is not the part of the question. If A has eigenvalues lambda as some lambda 1, lambda 2, and lambda 3. They are not asking you to check whether A inverse exists. So obviously, in this question, A inverse would exist. Okay. So the eigenvalues of this would be 1 by lambda 1, 1 by lambda 2, and 1 by lambda 3. So eigenvalues also gets reciprocal. And for A, because for if I take that as B, so if I know the eigenvalues of B, then what is the eigenvalue of B raised to power 15? You just do the power 15 for every eigenvalue that you have. All right. This you can prove in general also. In general also, let's say if A has in general, if let's say if A has eigenvalue lambda. So AX is equals to lambda x, right? You have to prove, proof is A raised to power k, x is equals to lambda raised to power kx. That means you see, eigenvectors does not change. Eigenvalues change. And eigenvalue will also be power k. This you can prove simply by PMI, principle of mathematical motion. So this was the small result used here. So if eigenvalue of A, eigenvalues of A are minus 1, and 8. Others, it implies eigenvalues of A inverse are minus 1, and 1 by 8. And it implies eigenvalues of A raised to power minus 15 are minus 1, and 1 by 8 raised to the power 15. Okay. with same eigenvectors as A. This is your last part. Which brings me to the next part here. Fourth B part. Acha. Now, let's just one more thing about this last this 4A question. As you can see, it can take so much of space, and you will not have that much of space in your answer sheet. So what you can do, although it's a 20 marks question, you'll have enough space. But if you think that if you are running out of space, then you can try doing some calculations in the rough work and write down the final result. For example, all the calculations that we did in finding eigenvectors, that can be easily compressed by doing major calculations in the rough work and writing down the final results. Okay, for example, calculation of this lambda can be avoided. Just from the equation 1, you can solve it in the rough work and you can write that lambda is -1 -1/8. So these are the small things you can do if you think that you're running out of space and it just involves calculations, so you skip those calculations. 4B part. Using double integration, find the area lying inside the cardioid and outside the circle R equals to A. So what is this cardioid? We have done this cardioid question in class. So what is the picture? How does it looks like? So cardioid looks like this. We don't have Y. In fact, we just have initial line, right? It's in the polar coordinates, so we just have initial line. And this is the pole. So cardioid looks something like this. It's not pointed, it's a curved surface here. And then we have a circle. Circle R is equals to A would be this circle. Yes. Note, using double integration, which area we need to find? Find the area lying inside the cardioid and outside the circle. So this area. Don't confuse, this is not the area we have to calculate. This is not outside the circle. This is inside the circle. So this area is not calculated. This is the only area, the shaded part that I have shaded here, this side. Okay. So this was very easy. You have the value of R also, theta also. So required area is double integration R dr d theta. So what is the limit of R? As you can see, it is outside A. So this point, R is equals to A here to this point, where maximum R can go up to A1 plus cos theta. So this is A to A1 plus cos theta. And theta is from here, it's minus pi to pi, minus pi by 2 to pi by 2. So it's minus pi by 2 to pi by 2. Okay. You just have to solve this integration now. This is what? This is r square by 2. So it's 1 by 2 outside minus pi by 2 to pi by 2. R square means a square 1 plus cos theta whole square minus a square d theta. So a square outside, a square by 2 minus pi by 2 to pi by 2. 1 plus cos squared theta plus 2 cos theta minus 1 gets cancelled, d theta. So using cos 2 theta is equals to 2 cos square theta minus 1, we get a square by 2. This is minus pi by 2 to pi by 2. This is 1 by 2 plus cos 2 theta by 2 plus 2 cos theta d theta. Let's do the integration. A square by 2, this is theta by 2 plus sine 2 theta by 4 plus 2 sine theta. Theta is minus pi by 2 to pi by 2. A square by 2 theta by 4 plus, this will be 0, 2 minus pi by 4 minus 2. This is a square by 2. 2 will get cancelled, and it's pi by 4 plus 2. You can write it as a square by 4 pi plus 8. That is your answer. Nothing else to discuss in this question. Next, 4C part, and the last part of the part A is this. For 15 marks, find the equation of the sphere. Find the equation of sphere. This is the sphere we're talking about. Okay. In analytic geometry, it's always better to start with a rough diagram. If you cannot imagine it, just mugging up the solutions is not going to help if you cannot see the things. So that is the sphere that we have here. Now, find the equation of the sphere which touches the plane. Touches the plane means it's going to be tangent plane. So let's say that is my plane, which has only a point of intersection. And now we'll have a point of intersection of the plane and this. And obviously, if I drop this perpendicular from the center, or if you say that if you draw radius till that point of contact, to that point of contact, that means definitely that will be a perpendicular line. Okay. All right. And it cuts another sphere given orthogonal. Okay. So for that, we have a condition. Right? Remember that condition? This is another sphere that it is intersecting but orthogonally. Let's move ahead. So one by one, we are going to apply all the conditions. All the conditions that is given for this sphere. See, there are majorly two things given for this sphere that we have to find out. That it touches the sphere. Okay, point is also given. Point is also given. And it cuts another sphere with orthogonally. Okay, so there are two major informations. So point is also given. So I have this point to be 1, -2 and 1. And now you see, if I take this point to be B and this point to be A, this B point is 1, comma, -2, comma, 1. Look carefully. Can we find equation of AB? That is very easy to find because I have a point on B, on AB as B given, and I know the direction ratio also. Since AB is perpendicular to 3x plus 2y minus z plus 2 is equals to 0. Therefore, a direction ratio of AB is, it can be taken as 3, 2 and -1, the coefficients of x, y, z. It implies equation of AB. What is equation of AB? X minus 1 divided by 3 is equals to y minus -2 divided by 2 and z minus 1 divided by -1. Please note here that you have to define first what, let A be the center of the this sphere and that B is the given point of contact. Please do write all these things, okay? And then you write this. Now, if you have equation, therefore, any point on AB is of the form 3t plus 1, 2t minus 2 and minus t plus 1, right? Also note that A is center of sphere. Let it be center of required sphere. Center of required sphere. A is center of required sphere. So, equation of required sphere can be taken as this point is in the center, the center, or this point is on the line AB, but A is also on the AB and A is the center. So I can say that center is also of this form, right? So equation of the required sphere can be taken as x square plus y square plus z square plus, what do we write? Plus 2ux, and u where this can be compared with minus u, minus v and minus w. So what is your u here? Plus 2 times minus 3t minus 1 x plus 2 times minus 2t plus 2y plus 2 t minus 1 z plus d is equals to 0. Is equals to 0. So equation of required sphere can be taken as this. If I'll take this as second, I take this as equation number 1. So since sphere given by equation 3, sphere given by equation 3 cuts sphere 2 orthogonally, then First of all, let me write down the condition. Just to remind you, what was the condition? If I take the general equation of a sphere as x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equals to 0. And similarly for another sphere, just take u prime, v prime, w prime and d prime. Then the condition is 2 times u dash plus v dash plus w dash is equals to d plus d dash. We know that they cut orthogonally, so this condition is satisfied. So it implies 2 times, here 2 is, this u dash is minus 2. Look at this here. We have minus 2, 3 and 0. UVW from here and D is 4. So minus 2 times minus 3t minus 1 plus 3 times minus 2t plus 2 plus 0 is equals to D plus 4. So this gives us 2 times 6t plus 2 minus 6t plus 6 is equals to d plus 4. Gets cancelled. 16 is equals to d plus 4 and here you get your value of d as 12. Okay. Now all you need to find this value of t, then you can substitute in equation number 3 and you'll get your required sphere. To do that, we know that AB is what? Radius. We know AB is radius, which means what is the formula of distance formula? AB. A is that general point, minus 3 minus t, comma, minus 2t plus 2, comma, minus t plus 1. This is A. And B, you know, 1 minus 2 and 1. So, AB. AB is minus 3t minus 1 plus 1. Because here we have, no, 3t, this is the formula, 3t plus 1 minus 1. It is going to be 3t plus 1 minus 1 whole square. Here I am applying distance formula. This side, I am applying distance formula. And there, that side I'll apply formula of the radius, u square plus v square plus w square minus d. Then we have 2t plus 1 minus 1 whole square plus minus t plus 1 minus 1. Minus t plus 1 minus 1 whole square is equals to radius. Radius is square root of u square, which is minus 3t minus 1 whole square plus v square minus 2t plus 2 whole square plus t minus 1 whole square minus d. Value of d is 12. I'll substitute that. And this plus 1 minus 1 cancel, plus 1 minus 1 cancel, plus 1 minus 1 cancel. So this becomes 9t square plus 4t square plus t square, squaring both sides. And this becomes 9t square plus 1 plus 6t plus 4 plus 4t square minus 8t plus t square plus 1 minus 2t minus 12. So this is going to be 14t square is equals to 14t square cancels out minus 4t, 6 minus 8 minus 2 minus 2 minus 4, yes. And then we have minus 6. This gets cancelled. So 4t is equals to minus 6. So t is equals to minus 3 by 2. That means you get the value of t also, you get the value of d also using 4 and 5. In equation 3, you get your required value. Okay. So using 4 and 5 in equation 3, obtain required square. I hope you can do this part. That is it for this video. I have solved all the questions of section A. So in the next video, I'll solve all the questions of section B, part A. That's it for this video. Thank you so much, everyone.